Hi, everyone. We're going to continue our discussion of the gas laws today. And today we're going to talk about the second gas law that you need to know for chemistry. And that is something called Charles's law. And Charles's law has to do with the relationship between volume and temperature. And again, before we go to the calculation part of Charles' law, I want you to think about a balloon. So let's say you blow up your balloon, you tie it off, and you take the balloon and let's say you put it on the dashboard of your car on a hot day where the sun can beat down on it all day and heat it up while you're in chemistry lab all morning, okay? When you go back out to the parking lot at lunch and see the balloon, after that balloon's been sitting in the heat, do you expect the volume of that balloon to be smaller or bigger than when you left it there? Well, as long as the balloon didn't pop, the volume of that balloon is going to be bigger. Now, if you go home and you take that balloon and you put it in the freezer in your house or even in the refrigerator and leave it there overnight, when you pull that balloon back out, that balloon's going to be smaller. So the relationship between volume and temperature is actually a direct relationship. If temperature goes up, volume goes up. If temperature goes down, volume goes down. Okay, so I'm going to share my screen again, and we're going to go through a calculation using Charles's law. Okay, so Charles's law is the initial volume over the initial temperature equals the final volume over the final temperature. But there's a real important note we need to be aware of when we're dealing with temperature and Charles' law. And that is that when you're plugging your temperatures in, temperatures always must be in Kelvins, not in Celsius. A couple reasons for that. The most obvious one, I'll give you time to think about it. What kind of numbers can exist in the Celsius temperature scale, but not the Kelvin temperature scale? If you remembered from last semester, you can have negative temperatures in Celsius, but not negative temperatures in Kelvin. Kelvin is an absolute temperature scale. There are no negative numbers in Kelvin. So you don't want to use Celsius because you could end up with a negative volume if you have a negative temperature, and you can't have negative volumes. We don't deal with antimatter in chemistry class. That's what the physics teachers deal with. Okay. Also, this proportion was developed using the Kelvin scale, which is an absolute temperature scale. All right, so let's go through a problem. So let's say we have our balloon, and our balloon initially takes up 500 milliliters of space. There's 500 milliliters of gas in that balloon. And let's say our balloon is at room temperature, which is 21 degrees Celsius. Okay, we're going to leave that balloon on the dashboard of our car in the back parking lot, and the temperature is going to get really hot in my car. The temperature is going to go all the way up to 37 degrees Celsius, which is about body temperature, which is 98 degrees Fahrenheit. I want to know, what's the new volume of that balloon going to be? All right. So the first thing you have to do, remember our note? You have to turn these temperatures into kelvins, okay? So you might want to have your calculator out for this. So all we're going to do is add 273 to each one, okay? So 21 degrees Celsius becomes 294 Kelvin, okay? And 37 degrees Celsius, if you add 273 to that, I think that's 300. No, it's 310, I think, isn't it, right? Let me just double check. 273 plus 37, yep. This becomes 310 Kelvin, all right? So again, just like with the last problem, I strongly suggest you do the algebra first before you plug your numbers in. So we start out with V1 over T1 equals V2 over T2. And what we want to have by itself is V2. So let's multiply both sides by T2. And that's going to give us V2 by itself on one side of the equation. So what do I have now? Now I have T2 times V1 over T1 equals V2. All All right. Now I'm going to plug my numbers in. T2, whoops, did I write T1 there? I meant T2, sorry about that. T2 is going to be 310K. V1 is 500 milliliters. And T1 is 294K. And again, before you plug the numbers in your calculator, check and make sure your units cancel out okay. And if you look at this, the units we have left is milliliters, which is a perfectly fine unit to have for volume. So let's take a look at this. So we have 310 times 500 divided by 294 is 527.2. So if I'm watching my sig figs, actually I only have one sig fig here. Let's pretend 500 mils had a decimal place after it, shall we? So we have our 3 sig figs there. And then we have 3 sig figs here, 2 sig figs here. So let's take this to 2 sig figs. So that would be V2 is 530 milliliters. Okay. Now, when you're doing these problems, it's always a great idea at the end to go back and see if it makes sense. Now, what's happening in this problem? Is the temperature increasing or decreasing? Well, in this problem, the temperature increased. So we would expect the volume to increase as well. And did the volume increase? Yes, it did. It went from 500 to 530 milliliters. All righty. I hope that makes sense. All right. Let's do one more problem with Charles' law. This time, let's use Charles' law to calculate temperature, shall we? Okay. So this time, let's say you have a gas and its initial volume, again, is 500 mils. Its initial temperature, what the heck? Let's keep it at room temperature, 21 degrees Celsius. And let's say this time, we're going to make this gas really, we're going to really increase the volume of this gas. I want to know if I want to double the volume of this gas, if I want this gas to take 1,000 mils of space, what temperature do I need to heat it up to? Okay, so this is a little bit of a different question. Okay, so let's start out with Charles's law again. V1 over T1 equals V2 over T2. Okay, and this time we're trying to find T2, which is in the denominator. Now I'm going to show you just a little algebra trick. You can flip this entire equation upside down. So let's do that. T1 over V1 equals T2 over V2. Now, why did I do that? Because I can. No, because I can. Algebraically, it's correct. It means the same thing. It still means that temperature and volume are directly proportional. Also, I think it makes the algebra a little bit easier for you if you flip, when you're looking for temperature, if you flip it upside down before you even start. Now, remember, we're trying to find T2. So let's multiply both sides of this equation by V2 so that we can get T2 by itself. So if we do this, we get T2 equals V2 times T1 over V1. All right? Now let's plug our numbers in. But remember, we got to turn this temperature into what? That's right, we have to turn it into Kelvin. Let's add our 273, and that makes our temperature 294K. Okay, so our second volume, V2, is 1,000 milliliters. T1 is 294 kelvins. Okay, and V1, the volume we started out with, is 500 milliliters. And again, before you plug this into your calculator, check and make sure your units cancel out. I'm left with kelvins, and that's a perfectly fine unit to be left with when you're talking about temperature. Let's plug these in. You have 1,000 times 294 divided by 500, and I get 588K. So T2 is 588K. That's really hot. How hot is that? Well, let's convert it into Celsius. To convert it into Celsius, all we do is subtract 273, and what we end up with is 315K. Okay, 315 degrees Celsius, which is really super hot. 315 degrees Celsius. Remember, boiling water is 100 degrees Celsius. So that's a pretty extreme temperature. All right. So when you're doing Charles' law and it's asking you to find volume, it's a pretty simple calculation, right? But when it's asking you to find temperature and you're using Charles' law, I highly recommend flipping the equation upside down before you start. It just makes the algebra easier, and it doesn't change the meaning of the equation. And remember, Charles' law says volume is directly proportional to temperature. If temperature goes up, volume goes up. If temperature goes down, volume goes down. That's different than Boyle's law. Boyle's law says pressure and volume are inversely proportional, which means if one goes up, the other one has to go down. Okay, that's Boyle's law. Charles' law, they both go up or they both go down. Hope that makes sense, and I'll see you guys next time. Bye.